Security detections are not one-time rules that remain useful forever. They depend on telemetry, environments, threat behavior, analyst workflows, and business context. Detection lifecycle management treats detections as living defensive assets. Each detection should have a purpose, owner, data source, expected behavior, documentation, review process, and improvement path. Without lifecycle management, detections can become noisy, outdated, duplicated, or ignored. A rule that once produced useful signal may lose value as systems, users, and threats change. The lifecycle mindset helps teams maintain a reliable portfolio of signals instead of a growing folder of unmanaged rules. Detection ideas can come from threat intelligence, incident lessons, threat hunting, red team exercises, vulnerability disclosures, business risks, compliance requirements, and analyst feedback. Not every idea deserves immediate development. Teams should prioritize based on relevance, expected value, available telemetry, impact, likelihood, and operational capacity. Prioritization prevents the detection backlog from becoming a random pile of requests. It helps teams focus on detections that are feasible, useful, and connected to meaningful defensive outcomes. A good intake process also captures context. The team should know who requested the detection, what behavior matters, what data may be needed, and how success will be recognized. A detection design should explain what behavior is being detected, why it matters, what data sources are required, what logic is used, and what assumptions exist. The design should also describe expected false positives, severity, enrichment, ownership, and what analysts should do when the detection fires. Good documentation helps future analysts and engineers understand the detection without guessing. It also supports review, tuning, handoff, and accountability. Detections that cannot be explained are difficult to trust, tune, or maintain. A clear design makes the detection easier to operate as a long-lived asset. Before deployment, detections should be tested whenever practical. Testing helps confirm that the detection logic works as intended and that the required telemetry exists. Validation also checks whether alert details are useful. Analysts need enough context to understand what happened, why it matters, and what should happen next. Testing may reveal missing fields, overly broad conditions, excessive noise, or assumptions that do not match the environment. These findings are useful because they prevent avoidable disruption. Detection testing is not about proving a rule will be perfect forever. It is about building confidence that the detection is ready for operational use. Deploying a detection is an operational change. Teams should consider whether the detection will alert immediately, whether it should run silently first, and who will monitor early behavior. A rollout should also define which playbook applies, how analysts will interpret the signal, and how unexpected alert volume will be handled. Careful deployment reduces surprise. It gives teams a chance to understand real-world behavior before relying on the detection fully. Managed rollout also supports trust. Analysts are more likely to use a new detection well when they understand its purpose, severity, expected context, and escalation path. Detection tuning is not failure, it is part of the lifecycle. Real environments reveal patterns that are hard to predict during initial design. Analysts may discover repeated false positives, missing context, unclear severity, or workflow problems. That feedback helps detection engineers improve the signal. Tuning may refine conditions, add exclusions, improve enrichment, update documentation, change severity, or adjust routing. The goal is better usefulness, not just fewer alerts. A healthy program treats feedback as a source of improvement rather than criticism. The detection gets stronger when engineers and analysts learn from each other. Detections should be reviewed over time. Useful metrics may include alert volume, true positive rate, false positive patterns, analyst feedback, coverage relevance, investigation outcomes, and time spent on triage. Metrics should support decisions. They help teams identify which detections need tuning, better documentation, improved enrichment, or deeper review. Some detections should be retired because the threat is no longer relevant. Telemetry changed, another detection replaced it, or the noise outweighs the value. Retiring detections is part of maintaining a healthy detection portfolio. It keeps the signal set focused, understandable, and useful. A mature detection lifecycle program defines how detections are requested, prioritized, designed, documented, tested, deployed, tuned, reviewed, and retired. It assigns ownership and encourages collaboration among detection engineers, SOC analysts, threat hunters, incident responders, and security leaders. The goal is not simply having many detections. The goal is maintaining a reliable portfolio of signals that helps defenders make better decisions. A strong program connects telemetry, threat knowledge, analyst feedback, and changing environments. It uses continuous improvement to keep detections useful over time. Detection lifecycle management treats detections as living operational assets. Effective programs manage intake, prioritization, design, documentation, testing, deployment, tuning, review, metrics, retirement, and continuous improvement. Detections should have purpose, ownership, telemetry, analyst guidance, and feedback loops. The goal is not to create the most alerts. The goal is to maintain meaningful signals that support defensive decision-making over time.